Welcome to the third session of the second module. Now, in the previous module, we have discussed. In the first module, in the first session, we have discussed the Lancashire boiler, and in the second session, we have discussed uh, the Babcock and Wilcox boiler. Then we have also discussed the working principle of both the boilers, and the comparison is also been carried out. And we found that the Babcock and Wilcox boiler has got more safety precautions compared to the Lancashire boiler. And in the Lancashire boiler, why can't we go for more precautions? It is as in the Babcock and Wilcox boiler, it is only the major reason is that the Lancashire boiler has got a bigger in size and efficiency is very less, around 65 to 70, whereas the efficiency in Babcock and Wilcox boiler is around 85% to 90%. And even the steam producing capacity of a Babcock and Wilcox boiler is 45,000 kgs per hour, whereas here in the Lancashire boiler or the fire tube boiler, it is only 9,000. And even the pressure, the maximum pressure of 125 kilopascals of energy or the pressure can be generated in a Babcock and Wilcox boiler, whereas here in this fire tube boiler, we will have a capacity of only 25 kilopascals. It is comparatively very less, isn't it? So, after all studying this, one point which I want to highlight it over here is the precautionary measures. The precautionary measures that have been taken in the Babcock and Wilcox boiler is much better than the Lancashire boilers. Now in this session, let us discuss what are those safety things that have been taken and what are these boiler mountings and accessories and what are their roles in the preventing the hazard, say in encouraging the safety precautions for any boiler. Now these accessories and the mountings are something like the supporting characters for a uh, hero and heroine in a movie. Okay, so these supporting characters, how they play an important role, I just shall go in depth. So this session will constitutes of functions of boiler mountings and then the functions of boiler accessories. So what are these mountings and what are these accessories we shall discuss in detail. So that will gives out a clear picture of complete boilers for a first chart. Okay, now if you consider the function of various boiler mountings and accessories, in first one, the boiler mountings are necessary for the proper functioning and safety of a boiler. Okay, without these boiler mountings, the boiler cannot work or function effectively or safely. The various boiler mountings are listed below. The few the, the boiler mountings are water level indicator, safety valve, pressure gauge, steam stop valve, feed check valve, and blow-off cock, and then the fusible plug. Now let us go one by one in detail what are the functions of these water level indicators or safety valve or different boiler mountings. Now this what is this use of a water level indicator? Basically, the function of the water level indicator is to indicate the level of water in the boiler drum and thus enables the operator to maintain the constant level of water in the drum. There exist two water level indicators in all the boilers. The water level indicators are fitted at the front and end of the boiler so that the operator can easily see it. Now, my dear friends, there will be two water level indicators will be there. That means even here also the more precautions is taken. If one water level indicator is not working, then the other water level indicator will does work certainly. So it has to be matching. So that is enough caution has been taken out. Now this water level indicator, sir, what happens if there is no water level indicator? Now you just imagine we have a turbine over here and this is a turbine and it has got so much of water. As I always tell you, there should be water for the formation of steam. If there is no water, how the steam will be formed? That is first point. And if all the water will be converted into steam and there is no water left over, then what happens? The heat, the pipes will starts heating the steam itself, and the steam heat enthalpy or the steam heat keeps increasing. So what happens? The pressure of the steam, if it reaches, for example, if you take a Babcock and Wilcox boiler, it works up to 125 kilopascals. If it reaches more than that, what happens? There may be a bursting of that drum may takes place, or there may be a blasting of this drum may takes place. That leads to a lot of damage. So obviously a constant water level temperature, water height has to be maintained inside the drum, and that can be monitored by water level indicators. Then the safety valves. Two safety valves are to be provided in the boiler as per the Indian Boiler Act. There is a one Indian Boiler Act standard is there. According to that, there should be two uh, safety valves. The one safety valve which always takes place Indian so that at least one of them is working. The same thing as we do it in the water level indicator. These are mounted on the top of the boiler. It is always mounted on the top of the boiler, where the function of the safety valve is to safeguard the boiler when the pressure inside the boiler reaches above the working pressure. So that is what every boiler drum, every boiler, not only Babcock's and Wilcox, not only Lancashire, not only Cochrane boiler, not only any other boiler, any boiler has got its own limitations of generating the steam and its pressure. If this pressure exceeds, then there will be a blasting or accidents is meant to occur. So what happens? This safety valve will be always placed at the top of the boiler, wherein which if the boiler pressure reaches more than its level, then what happens? Automatically it just opens up and releases the pressure without anybody's instructions. That is the importance of this safety valve. Automatically it just opens up. And even, my dear friends, point to be noted, this safety valve is also there in our pressure cooker also. Even in our pressure cooker also there is a safety valve. If you see that the top, apart from the dead weight safety valve and the visual, even on the side you can see a hexagonal bolt like structure. A hexagonal bolt like structure, it is nothing but a safety valve. So this is being used in order to avoid the accidents. Okay, avoid the hazardous things to happen. This is automatically, this is what actually thought I have not done even. So this is automatically done by opening up of the valve and discharges of the steam to the atmosphere soon as the pressure inside the boiler exceeds the working pressure. That is what. Once it reaches suddenly, if this is a safety valve like this, whenever the pressure exceeds more than the working level, then automatically it just opens and releases the pressure. Once it comes down, then automatically it just closes. That is the beauty of this safety valves, and anybody should expect this to be there. So there will be two safety valves. If one is not working, then the other one will also be working. It will operate it. The commonly used safety valves include dead weight safety valve, spring loaded safety valves, and lever safety valves. No, this is the same safety valves only. Dead weight safety valve means this is made as a very heavy one. It falls down because of its weight. Once the pressure comes down, it falls down because of its weight. M into G, mass into gravity, it makes it to fall down. And the second one is there will be spring operated. Spring will expand, and then if the pressure is released, spring will compact. That is the one thing. And if it is a lever operated, we can operate it by a lever. That's it. Three types of safety valves are also being used. Then the pressure gauge. The pressure gauge is used to measure the pressure of the steam inside the boiler. So that means we have to monitor. So whatever the steam that is being generated, the steam will be taken to the turbines, and the turbine will be rotating. So the turbines need a prescribed a known amount of the steam pressure. If the turbine has to operate or to begin, it should be maybe around 10 bars, or it may be with so and so pressure. So the required pressure is needed for rotating the turbine blades. So in order to maintain that, what they will do it is they will check the pressure of the steam which has been forming constantly. Once it reaches, then they will take it into the turbine. Now, if you consider the pressure gauge is being used to measure the pressure of the steam inside the boiler, the most common type of pressure gauge is the Bourdon tubes. The Bourdon tubes are the most normally in general uh, used pressure gauge which reads the pressure. It will always have a small a spring like or a circular like structure. Whenever the pressure increases, it keeps outfilling it, and it keeps expanding it. Thus, it gives out the reading of the pressure that is being generated. That is the principle of working of Bourdon tube that is not discussed. So, it is one of the pressure gauge that is being mostly used. It is fitted in the front of the boiler such that the boiler attendant can easily read it. So most of the times, every 10 minutes or 15 minutes, or it may be half an hour, or it may be 1 hour. So what they will do is they will keep monitoring the pressure rise. Okay, junction wall or steam stop wall. This is what we call it as. This is called as a stop wall, or this is called as a junction wall, or this is also called as a steam stop walls. Steam stop wall or a junction wall is mounted directly on the boiler and is connected to the steam pipe which leads to the engine. It is operated by hand and its function is to regulate the amount of steam passing through the steam pipe and to shut it off when it is required. When there are a number of boilers delivering steam to a main pipe, each boiler must have its own junction wall. What happens in a power plant, in a thermal power plant, what happens? There will not be only one boiler. There will be a number of boilers. For every number of boilers, there will be a main channel. The heat from this boiler will be connected to this. The heat from this, the second boiler will also be connected to this, and the heat from the third, steam from the third boiler. Whatever, if there are 5 number of boilers are there, the steam will be taken from all the 5 boilers to the main channel. So what is the amount of heat is required for the turbine which will be sent? Say for example, so it is only because the only one turbine or one boiler cannot fulfill the requirement of a boiler. Turbines. Turbines are very huge in size, my dear friends. This turbine cannot be fulfilled with the steam that is being generated by a single uh, boiler. So that what happens, they will be always connected. So every boiler, what is the amount of steam that is being supplying will be handled manually, and this will always restrict, or it will allow the steam to join to the main pipeline or to the turbines. That is the use of this boiler steam stop valve or a junction valve. Feed check valve. Feed check valve. The function of the feed check valve is to maintain the level of water in the boiler drum constant. That is one thing. It is fitted to the boiler slightly below the working level of the water in the boiler. It is connected to the boiler end of the delivery pipe from the feed water pump. The feed check valve consists of two parts. One is the feed valve and the other one is a check valve. Now, we have already indicated there is a one water level indicator which checks the water level in the drum. Apart from that, there is a one sensor based feed check valve will be there, where it will have two things. One is a feed valve and the other one is a check valve. What happens is, now you just imagine this, my hand is a turbine drum. Now this is being fixed at the bottom portion of this feed check valve, and it will have two valves. One is a feed valve and the other one is a check valve. What happens whenever it finds there is a decrease in the water level, automatically it just opens the feed valve. Feed means you have to feed it, correct? So feed valve will be open, so the water source, maybe yes, any water source, it will be connected. It will pump the water and it will take the water into the drum. And once if it reaches to the required level, then automatically it will switch on to the check valve. Check valve means it restricts or it stops. It closes the movement of the water. So that is what we call it as a check valve. So it feed valve will be open when there is a water level is reduced. It will open the water to go inside the water drums, and once if it reaches the enough sufficiently enough into the drums, then it will switch off the feed valve and it will closes. It will open. It closes the valves with a check valve. Check valve means it closes the movement of the water. That is the use of this feed check valve. Automatically it just operates. It is always fitted to the boiler slightly below the working level of the water in the boilers. Next one is a blow-off cock. Blow-off cock or a blow-off valve is also called. It is necessary to periodically empty the boiler in order to clean and inspect internally. Okay. It is also common practice that the portion of water from the bottom of the boiler is periodically discharged so that any sediment deposited may be carried away or it will be taken away. For the purpose of a blow-off, for these purposes, a blow-off valve or a cock is fitted at the lowest part of the boiler. Now, my dear friends, if you take this as a boiler, or if you take this as a boiler, the blow-off valve will be always placed at the bottom like this. It is always placed at the bottommost portion like this. This is called as a blow-off cock. Now, blow-off cock, if you open it, completely whatever the thing, whatever the water or whatever the sediments which is being present in the turbine will be taken away. So that is what the use of a blow-off cock. Why is this blow-off cock is used? Now what happens, my dear friends? Maybe very rare, 6 months once, or it may be a yearly once or yearly twice. What happens is we have to clean the drum or the boiler drum clean. We have to clean it and we have to make it neat for the collection of next water or the formation of the steam. It's only because whatever the water we are supplying it, we cannot keep filtering it to the maximum. Though we filter it and pre-treat it, it will have some dust particles which it is difficult for filtering it. And even if you are using a salt water, it will always have an dissolved salts or hardness will be there. So what happens, it forms as a sediments or it forms as a scaling also. Scaling is something we have to remove it, and sediments are the dust or the sand particles or the dirt particles which settles at the bottom. Okay. Once we have to clean it, then we cannot keep pumping it outside. So what we will do it is, we will drain it, we will make it empty with a blow-off cock. So once we open it, everything will comes out. Everything will not comes out, but only the water, the sediments, it will clear to the maximum or 90%. It will take away everything. Then what happens, there will be one more called as a manhole will be there. Manhole, that means a hole is made of in a drum which can, wherein which people can go inside that with a ladder. What they will do is, they will go inside and they will clean it manually everywhere, and they will, whatever they are going to clean it will also be taken out with the blow-off valve. That is the use of this blow-off valve. Okay. Now in one better example, what I can do it is, even in your water tank, even in a syntax, if you see that syntax, if you want to clean it, how do you clean it? Apart from the intake water, below that once again there will be a valve will be there, or the nut will be there. If you open it, what happens? Whatever the sediments, whatever the waste that is being settled at the bottom of your syntax will be taken out, right? So the same purpose is being done with the blow-off cock. Okay, and this is also called as a drain valve also. Okay. Then the next one is, last but one I guess, the fusible plug. The crown of the furnace or the combustion chamber should be fitted with a plug held in position by the fusible metal of alloy. The main object of the fusible plug is to put off the fire in the furnace. Put off the fire in the furnace of the boiler when the water level in the boiler falls below the unsafe level. Okay, thus avoid explosion which may take place due to the overheating of the fuse and the shell. Now, this fusible plug, it is something like a controller. So what happens? This is always placed on the near the combustion chamber. So what happens? The combustion, it controls or monitors the combustion of the fuel. Whenever if it identifies that the water level in the drum, if it falls below the unsafe level, is it clear? So whenever this water level goes below that level, if you keeps heating it, what happens? It may leads to blasting or bursting of the turbine tubes or overheating of the superheater or anything. So what we will do it is we have to shut down the combustion. How we can shut down the combustion immediately? So by this fusible plug control, automatically it will sense the water level indicator, and whenever it is been instructions is been given, it automatically shuts down the combustion so that the heat will not be there. If this is been prevented, then automatically it will not supply the heat. When this is not been supplying the heat, then there is no point of overheating, or it will also avoid the explosions which may take place due to the overheatings. That is the use of this fusible plug. Now, though they are all the boiler mountings which will be directly placed inside the in the for the drum, which are necessary for the safety. So those mountings are meant extensively for the safety of the boiler. Okay, now let us talk about the boiler accessories. Now this boiler accessories, the boiler appliances called accessories are required to improve the efficiency of the steam power plant and to enable the proper working of the boiler. Is it clear? Now this how we can make the steam power plant in a proper working condition. It is only by using boiler accessories. They are not mounted directly onto the boiler. This is what I have highlighted here. Whereas boiler mountings are, they have been placed or they have been fixed or mounted on the boiler drum itself. Whereas these accessories are not fixed onto the boilers accessories. Correct. So few of that are a superheater, economizer, air preheater, feed pump, steam separator, and steam trap are the majorly important one. Now let us go one by one. Steam trap and steam separators. Now superheater, as I have already explained you what is the use of the superheater in a Babcock and Wilcox boiler, as it will be always separated by the drum. This superheater This superheater is a device which is being used to convert the dry steam generated by the boiler into the superheated steam to increase the thermal efficiency of the boiler. Basically, this superheater can also be defined as the one which converts a wet steam into a dry or a superheated steam, which is of required steam for the any sort of turbines. It is set of it will have a series or a set of tubes which have been placed in the path of the flue gases, and these superheaters doesn't carry the water. Please be careful. This mainly carries only the wet steam which has been formed in the initial stages of the formation of steam. So its only duty is to convert this wet steam into the required dry saturated steam, or it may be a superheated steam. In most of the occasions we would always go for the superheated steam, which will have a higher potential of converting that heat into mechanical energy by rotating the blades of the turbines. The steam from the boiler shell is being passed through the superheater, where it has to be absorbed heat from the flue gases, and then it converts into the superheated steam before it reaches into the steam stop valve. Steam stop valve I have already discussed with you. It is a one valve from which the superheated steam will be piped out to the turbines. Okay, before it reaches that, what happens is it converts that water into the wet steam into the superheated steam by the use of the same flue gases which have been used to convert the water into the steam. So the same flue gases will be used for the conversion purpose. Now let me talk about this economizer. Economizer is a heat exchanger that raises the temperature of the water before it enters into the boiler drum. Now, before I just explain what is this economizer, I would have told you about an heat exchanger. Basically, this heat exchanger, it can be or it is a device which converts or which exchanges the heat between two fluids. It can be air to air or water to water, or it may be one liquid to the other gas, or it may be from gas to the any liquid. That is what the use of a heat exchanger. It can be any. It can be used in even in the domestic applications also. One of the better heat exchanger what I can give you is the radiators. In automobile applications, radiators have been extensively used in order to take away the heat that is being generated in the engines. Okay, now this economizer is one of the type of a heat exchanger which raises the temperature of the water before it enters the boiler drum. Okay, now its function is to extract heat from the outgoing flue gases which you have left out to the chimney before it enters to the chimney, and this heat is being used to preheat the feed water. Hence, the most of the heat from the escaping gases is being utilized. It is something like a waste heat recovery purpose. Now, this is too early for you people to talk about waste heat recovery. Now, let me not dig into that. Come back to the economizer, which has been mounted in the path of flue gases just before the chimney and after the air preheater. Now, air preheater and economizers are the two most beautiful devices which makes use of the waste heat also. When I was talking about the Babcock and Wilcox boiler, the heat or the flue gases which have been channelized and the heat that will be carried away by the gases, and then it will be left out to the chimney. Before it leaves to the chimney, whatever the done work by the flue gases which is being left out is being utilized by this economizer. Economizer, what it does is, whatever the water that we are just feeding into the drum will be heated up, so that what happens, the energy which is required to convert this warm water will be utilized. So this increases the thermal efficiency of a boiler also. Is it clear? That is the major advantages of this economizer. Economizer utilizes the waste flue gases which have been left out before the chimney to convert a feed water temperature which used to raise the feed water temperature before it entering into the boiler drum. Thus what happens, the energy which has been already heat, energy required to convert this warm water or a hot water will be reduced. Thus increases the thermal efficiency, and it also reduces the overall cost or an expenses in converting the steam from the water. That is the one most beautiful applications of this economizer. Similar applications are also I just discuss with the air preheaters. As the name itself indicates, air preheater, that means we are heating it prior than it is which enters into the combustion chamber. Now, in the combustion chamber, unless otherwise you supply a primary or a secondary or a tertiary air, it doesn't burns effectively or efficiently. This air which we are supplying should not be cold. As much as the temperature of this air is more, the more efficiently that burning or combustion does takes place. So the same thing, whatever we have done it in preheating of the water which we are supplying it to the drum, similarly we will also heat the air which has been supplying into the combustion chamber with the same principle. This preheated air eases the burning of the fuel and hence improves the efficiency of the boiler. It is been mounted in the path of the outgoing flue gases before the economizer. So conceptual wise, Soon after the flue gases, it gives away most of its heat to the superheater and even for the water before it reaches to the chimney. First, it will passes over to the preheater, then it will passes through the economizer, then it will left to the chimney. So this is the maximum utilization. So I always rate this air preheaters and economizers comes under the similar category of waste heat recovery. It is something like, what do you mean by waste heat recovery? The one which we treat it is a waste will be utilized. That is what we call it as a waste heat recovery. As the air before entering to the furnace passes through these preheaters, it absorbs heat from the surroundings and its temperature increases. Obviously, it is quite obvious. The common sense says it increases the temperature and thus increases the efficiency of the boilers as well. Next one is the feed pump. A feed pump is an accessory required to deliver the feed water to the hyper. It is something like a feed pump is nothing but it's a pump which is required to pump the water to the drum. That's it, nothing else. As we use a pump in our domestic applications to pump water from the lower level to the syntax, same way this feed pump is being used. The commonly used feed pumps are a rotary pump, reciprocating pump and injector pumps. I'll go in detail about this feed pump when I talk about the third chapter of the second module. So soon after this chapter we might go for that. Okay, next one is a steam dryer or a separator, where the steam separator separates the suspended water particles in the steam before it enters into the turbine. Now this steam dryer or a separator is a part of boiler as well as it is a part of the turbine as well. It is located very close to the turbine and the main supply pipe. Steam trap. Steam trap is a device used to drain off the condensate water accumulated in the steam pipe lines, while at the same time the high pressure steam do not escape out of it. That is the use of the steam trap. It is connected to a small bypass pipe which branches off from the main steam pipeline. These are the few assignment questions.